Okay, now the concept of restriction is applied in sine, cosine, and all the trig function. So you see from the last, you need to know if you take the inverse of this one when you solve, right? So you have so many of them. Okay, you have so many times you're going to have the inverse look like this. The inverse look like this. So inverse look like this. Then these are not a function. If you take the inverse this point to this point, this point to that point, you know, this point to this point, whatever. So these are not a function. Therefore, we have to decide to restrict the function side into the one-to-one function. Okay. So that means when you draw the line test, the Hometown test have to go only once. Okay. So the most logic, the last class everybody agree, we restrict from here to here, right? You see the most logic here from here to here. You can do from here to here, but it's too complicated, right? You can do from here to here also the inverse function, also the one-to-one function. You can do from here to there too, one-to-one function. But this one hard time. You focus on closer. This one easier to work out. Okay, then everybody agree. Okay, the inverse function happen only here, from here to here. So what quadrant? So why we need to know the quadrant? So this one quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, look, from 0 to 90, from 0 to 90, this one quadrant 1. Okay, from 90 to 180, 90 to 180, which is quadrant 2. Okay, from the 0 to negative 90, go this way. Okay, that is quadrant 4. Okay, from negative 90 to negative 180. Okay, from negative to negative 180, you have quadrant 3. And if you keep going, you know, quadrant 2. So I use the degree for you to understand it, but it's wrong to use the degree in this case. Okay, when the graph function, you cannot use degree, but I use degree for you to understand. And later on, you have to change everything into radian. Okay, especially when you graph the function, you have to change it to radian. Now, since we don't have this one, we don't worry about this. So the answer of the inverse function has to be in quadrant 1 and quadrant 4. For example, I asked you to find sine inverse of root of 3 over 2. So there are two answers. So one of them is 240 degrees. Okay, let's say negative root 3 over 2. So, root 3 over 2, that's fine. So your answer is, one answer is 60 degrees. The other answer 120 degrees, right? So 120 degrees, you have 120 here. So reference angle equals 60, then root of 3 over 2, sine equals root 3 over 2. Sine of 60, also root of 3 over 2. Sine of 120, also root 3 over 2. But this is a wrong answer because this one not in the domain of the inverse. So we restrict the domain of original function. You restrict from here to here. Okay, so your answer right here is not correct. The answer is 120 degrees right here. 120 degrees is not correct. Your answer have to choose in the first quadrant, which is right here. So okay, right here, this one 60 degrees. This one root of 3 over 2. This one also root of 3 over 2, and this one 120, but this one outside of the domain of original, right? Restriction. Okay. So now how about cosine? So let me give you another example. So if I want to find sine inverse of negative 1/2, so you take a look at negative 1/2 can be 210 degrees. You see all the way from here to here, all the way from here to here. So there are negative 1 to negative root of 3. We go in quadrant 3, the value side negative, right? So then 210 degrees equal negative 1/2, right? However, this one it belongs to quadrant 3. The answer here is not correct. You have to choose this answer here. Also negative 1 over 2 here, root of 3 here. So now sine of 330 degrees. Okay, this one is 210 degrees and 330 degrees and many more. But you see this one wrong because it belongs to quadrant 3. So west side belongs to 4 and 1 only. So therefore you have to choose this quadrant 4 right here. Okay, the value of 330 degrees. Mean negative 30 degrees somewhere right here. Okay, negative 30 degrees. This one negative 90 degrees. Okay. Okay.